For the foci, those come from the C value, which is how far away each of the foci are from the center. So they come from an ABC relationship. For the ellipse, it's a squared minus b squared equals c squared. For hyperbolas, it's a squared plus b squared equals c squared. So plus in the equation, minus sign in the ABC relationship, minus in the equation, plus in the ABC relationship. So now we're going to use our a squared and our b squared to figure out what our c value is. So our a squared is 25. Our b squared is 4. So c will be equal to plus or minus rad 21. We need the plus or minus because that shows me that we're going to be moving up and down from the center since it's vertical. If it was horizontal, the plus or minus would be moving us left and right of the center. So that's going to be our c value. Now for the a squared plus b squared equals c squared 1, our a squared is 4. Our b squared is 16. And I go to my math lab, I say c equals 20, and it's wrong. Why is that wrong? Why is it not quite all the way there where we want it? Simplify it. So take out a perfect square of 4 and the non-perfect square value of 5. And that gives me c is plus or minus 2 rad 5. So don't forget to simplify your radicals. So in this section, we get into the vocab. So who's got a major and minor axis, hyperbola or both? Only the ellipse.
Yeah.
So nothing for the hyperbola, nothing for the hyperbola. Who's got a transverse axis and a conjugate axis? Hyperbola. Right? So, nothing for the ellipse there. Who's got vertices? Both of them do. And the vertices come from the a value for both of them. Who's got covertices? Just the ellipse. Very good. Hyperbolas have those endpoints which aren't very useful to us, so only the ellipse has the covertices. Who's got foci? Both. And those both come from the c value. Who's got asymptotes? Hyperbolas do. So remember, we need those slanted dashed lines because that shows us how wide those swooshes are going to get on the side. So ellipses are out, hyperbolas are in. All right, folks. So now that we've kind of distinguished between the two, we're going to ignore this side for right now, and we're just going to focus on actually graphing this ellipse. So we're going to start with the center. It's at 3, -1. So 1, 2, 3, -1. C for center. If this is a vertical ellipse, are my vertices going to be stacked this way or this way? This way, in the up-down direction. So the vertices are always on the A axis, either the major axis here or the transverse axis over here. So our vertices need to be stacked up and down. So we are going to move A units up from the center. 1, 2, 3, 4, 5. And then A units down from the center. 1, 2, 3, 4, 5. And those are our vertex points, giving me a major axis length of what? 10. Your major axis length will always be 2 times the A value, because if it's 5 units from here to the center, 5 units from the center to the other vertex, that gives you a grand total of 10. So if my vertices were stacked this way, up and down, how are my covertices going to be stacked? This way, side to side. So for the covertices, I'm going to move B units from the center. So 2 units to the left, boop. 2 units to the right, boop. And that's what we need to draw the ellipse. And remember, we want it to look more like an egg and less like a football. Do your best. So our co-vertices are on the minor axis, which has a length of 2b, so 4. Now, for the vertices and the co-vertices, to state these as coordinates, you could pull them directly from the graph, or I'm going to show you how to find them algebraically, because that's what we're going to do with the foci as well. So on these term review instructions, you'll notice that on some it's like, hey, you may want to draw a diagram. So that might be on a problem like this, just to make sure you have things stacked correctly. We did a lot of diagram sketching in Unit 2, and it's very, very helpful for this test. So folks, if I wanted to find the vertices, I could just pull those points from the graph. But if I know that this is vertical, I know that my vertices are going to affect the y value, that I need to move up and down from my center by 5. So if I move up by 5, we add 5 to the y value, and we get 3, 4. And if I move down by the a value from the y value, -1 minus 5 will give me -6. And we would see that those 2 points match up with the ones from my graph. I can use the same strategy with the covertices. Since the covertices are moving left and right of the center, those are going to affect the x value of the center. So if I move left by 2, by subtracting 2 from 3, we would get 1, -1. And if I move right by 2, we would get 5, -1. And we can see that those points match up with the points that I have graphed. Now for the foci. Actually, before we do the foci, anybody have any questions? These are tough. There's a lot of vocab here. These are very involved problems. Luckily, you won't have to do like all of these steps for like one MyMathLab problem. Usually it'll be like complete the square, what conic section it is, or complete the square, where's your center located. So don't feel like you're going to have like monster questions like this on the test. Hopefully doing the MyMathLab term review gets you more comfortable with the types of questions that will be on there. These are just good because they cover everything for each type of conic section. So for the foci, those are going to be C units away from the center. And how are my foci going to be stacked? Up and down, left and right. Up and down, because those foci are always going to be along the major axis for an ellipse or the transverse axis for a hyperbola. Your foci and vertices are always on the same axis. So if my C value is plus or minus rad 21, who's going to get affected? My X or Y value if I'm going up and down? Our Y value. So I'm going to take my center, 3, -1. I'm going to do plus or minus rad 21. That shows that for those two coordinates, I'm going to move up from the center and down from the center. And remember, my math lab is all good with that notation, but if it asks for like the left foci and the right foci, then you'd have to write them as two separate points. And just for fun, putting those foci on the graph, rad 21 is about 4.6-ish. So if we went 4.6 up from the center, it's super close to the vertex. 4.6 down from the center, super close to the other vertex. So foci, foci. That's a wrap on the ellipse key features. So remember, in Unit 2, we had 3 conic sections and then completing the square. So shorter chapter, but there is a lot here. It was a long time ago when we did this Unit 2 stuff, so spend some time with those vocab pages that we mentioned above. So folks, moving on to the hyperbola. The transverse axis length, similar to the major axis, has a length of 2a. It's just not necessarily the longer axis. So this would have a length of 4. My conjugate axis is 2b. So this will have a length of 8. But remember, the conjugate axis, we don't normally graph because it connects those endpoints, so you might have to state the key features, but it's not going to be very useful to us for graphing. For the vertices, we're going to use our graph and the algebra skills like we used for the ellipse. So we're going to start by plotting our center on the coordinate plane. We've got -1, 2. Backward 1, up 2. There's the center. Now, our hyperbola is horizontal, so which way are my vertices going to be stacked? This way or this way? This way. Vertices always go with the orientation, so do the foci. So our vertices are going to be horizontal, so I'm going to go A units from the center horizontally. So I'm going to go left 2 from the center, vertex number 1. Right 2 from the center, vertex number 2. There's my transverse axis, which connects them, but again, it doesn't really give us the shape of the hyperbola like our major and minor axis do for the ellipse. To find those coordinates, we can pull them directly from our graph, or if I'm going to move horizontally by 2, the x value of our center is going to get affected. So -1 left 2, -1 minus 2 would give me -3, 2. And then moving right by the a value, -1 plus 2 would give me 1, 2. See if you can write the coordinates of the foci using that plus or minus notation, knowing that they need to be in line with the vertices. So to move left and right from the center, we would have -1 plus or minus 2 rad 5, and then 2. 2 rad 5, I believe, is about 4.5. So we're going to go 1, 2, 3, 4.5 from the center. 1, 2, 3, 4.5 from the center. And that gives us our foci. Now, if you're looking at that going, this doesn't really look like what I remember a hyperbola looking like with, the swooshes, kind of like 2 parabolas. That's because to get the shape of it, we have to figure out the slope of the asymptotes. So, for slope, what we chose to remember is plus or minus rise over run. If you look in your notes, you'll see that it's either A over B or B over A. But rise over run gives us an easy way of remembering which it is. So plus or minus rise over run. So we're going to zoom out. And we're going to go up to our standard form equation. Who would you say is our rise variable, y or x? Y. Y is rise, which means our rise value comes from b. So our rise will be 4. Our run variable is x. So A will be our run. Don't forget that plus or minus in front. And don't forget to simplify. Plus or minus 2. So rise is y, b value. Run is x, a value. Remember, a squared and b squared is how they appear in the equation, but for all the fun graphing stuff we did down below, it was only the a and b values, not the a squareds and b squareds. So using our asymptote slope, we're going to go up to over 1 from the center. There's one asymptote. And then up to back 1 from the center. There's that negative slope in action. And then to draw the hyperbola, we swoosh through the vertex towards those asymptotes. And that concludes Unit 2.